Hi, this is Dr. Steven Seiler. I get asked a lot on Twitter, during webinars, during different situations, how do I find my maximum heart rate? Because obviously, heart rate gets used a lot to help us gauge intensity. So, in this video, I'm going to spend some time talking about exactly that. How do we actually determine our individual maximum heart rate? Now, I have previously made a video about this issue of using prediction equations to estimate your maximum heart rate without actually testing it. So if you're unsure about that, you can go to that video. But the bottom line on that is that these equations are based on population data or large samples like this one. This is 157 cyclists that our lab has tested, ranging from 18 to 63. And basically what you see is at the same age, you can have big variation in maximum heart rate. So I don't recommend using these formulas for that individual determination. Says something about the population, says something about aging, but isn't very useful at individual level because of this spread. So way back 30 years ago, a professor named Frank Inge here at the Norwegian, then it was the Norwegian College of Sport in Oslo, he was testing lots of endurance athletes in Norway. And he says registration of heart rate and use of intensity scales based on maximum heart rate is widely used to control or verify work intensity, particularly endurance athletes. But the usefulness of such scales depends on heart rate values obtained from a reliable heart rate max test. So what do those look like? Well, he did a very robust study that I'm going to show you some data from in this video. Now, another little quote before we get started was from another paper that I'm also going to show you some data from, and this was done about 10 years later in 2002. It basically says the same thing in a different way, that intensity is used to describe our work, but what do we mean with intensity? Do we mean speed, heart rate, percentage of maximum heart rate reserve, which is just maximum heart rate minus resting heart rate, or percentage of maximum oxygen uptake? A lot of this is lab based traditionally. Can we do it in the field? So these are questions that both of these investigators pursued, and these are underappreciated studies that I'm going to dig into and show you what I think they mean. So the first one was this study from 1991, coming up on 30 years ago, a professor named Frank Inge. I'm not sure he's with us anymore, but he was still alive and working when I moved to Norway 25 years ago. And he did this study on 59 subjects, mostly male. They were 19 to 28 years old. They were competitive endurance athletes. And they had, on average, a good VO2 max, 65 mLs per kg, some a bit more, some a bit less, but clearly well trained. And because of the amount of testing they did to look at different questions, they divided this big group into different sub-studies where 10 to 19 of the total subject group did the different studies. So, for example, the first question was, what's the effect of the warm-up? And this gets asked a lot. So they compared a 30-minute warm-up at 60% of maximum intensity or VO2 max with a 10-minute warm-up. And this was 10 athletes who came into the lab, did these VO2 max tests on different occasions, either preceded by a 10-minute warm-up at 60% of VO2 max, meaning easy, slow running, or a 30-minute. So they didn't do any high intensity strides or anything. They just did 30 or 10 minutes of low intensity running. Did that make a difference? Well, yes, 9 out of 10 athletes reached a higher heart rate peak with the longer warm-up. Now the average difference was 4 beats. That doesn't seem like a lot, but clearly the warm-up does matter, and we might even say an optimal warm-up would include some high intensity bouts, just short strides to kind of turn on the engine. But at any rate, the warm up does matter. Now, another question they asked was, what if I test on consecutive days? They were basically asking the question, what's the issue of fatigue? Or does it matter if you've been doing a lot of hard training, maybe you did a race yesterday and now you're going to come in and test, or you're going to do another race today? Well, indirectly, they were testing this issue. And what they saw was when they had athletes come in, here we had 19 highly trained cross-country skiers, both males and females. They came in on 3 consecutive days and tested. And what you see is actually across just 3 days already a clear decline in their average maximum heart rate. You see that 14 out of the 19 had their highest heart rate on the first day, 5 on the second, and none on the third. So there was a general decline in max heart rate. So clearly, it's a basic rule is you're not going to hit maximum heart rates if you're not rested for the test. And if we extend that a little bit, you can begin to say, well, that probably also applies to racing. You're not probably going to be at your best 3 races in a row at almost maximum or maximum intensity. By the end, you will probably not be able to mobilize a maximum effort. Now, another question they ask is, what happens if we use different combinations of running time and kind of break it up into intervals? So this is kind of the interval session simulation to find maximum heart rate. They had the athletes do the 30-minute warm-up. Then they used 3 or 4 minute intervals, either 2, 3, or 4, I should say, all out. And what they saw was that peak heart rate did not happen on the first bout. It tended to happen, or it didn't happen at all on the first bout with a 2-minute duration. It tended not to happen even with 3 and 4 minute durations of a all-out run on the first bout. But if they did one bout, rested for 2 or 3 minutes, and then another, I believe it was 2 minutes, then on the second bout, they hit their peak or a higher maximum heart rate. By the third bout, they were starting to fatigue. So in general, 2 minutes is too short. 3 or 4 minutes times 2 is probably pretty good. And so you can almost do a heart rate max test as a short interval session, but at least the second bout doing it basically all out, choosing the right pace so that you're coming across the line in 3 or 4 minutes just as hard as you can, or having run as hard as you can. Now, another question this group asked was field versus lab testing. Are the heart rates different? And at this time, you have to remember that heart rate monitors weren't that normal, but they were around. The Sport Tester, I think it was the 3000 model, was available. But treadmills weren't very common either outside the laboratory. So if you said, go find your maximum heart rate, that was the first field test. The athletes were just told to go find their heart rate without giving them any instruction on how to do that. And that didn't work very well. They did not reach their peak heart rate under those conditions. In the second field test, they were told how the laboratory test was organized and then told to reproduce that. And then heart rate max is closer to what they see in the laboratory. And then the actual all-out lab test you see had the highest. That's where 11 of 14 athletes hit their highest peak. So in general, at least at this time, the field tests didn't usually give a maximum result. That may be because of motivation. It may be because also if they were running on roads, there may have been small changes in incline that would kind of mess up or result in them not running at maximum speed near the end of the test. It's hard to say, but in general, the laboratory conditions gave better, more predictable true heart rate max values, or at least higher values. What about treadmill incline? This was part of that same study with 3 consecutive days, but the incline of those tests was in a randomized order, and you see a 1 degree, 6 degree, or 12 degree incline. 6 degrees is 10.5%, just so you know. And what you see is basically it didn't make a difference. Different athletes hit their peak on different of these inclines. Just as an interesting point, this is the treadmill incline that cross-country skiers in Norway have been tested at for 30 years and counting. It's 10.5%, and probably may have been based on this study, I'm not sure, but at any rate, it's been the standard way of testing cross-country skiers. That way they don't have to actually run very fast, because fast running is not what they're trained to do. Whereas track athletes, they use 1% incline. Orienteers, they use 5% incline. So it's a little bit individualized based on what the athletes are used to do in their training. Now, another question is interesting to me is, does reaching VO2 max ensure that you've also reached heart rate max? Now look at this. What you see is on the y-axis the heart rate max achieved during heart rate max testing. So they were just trying to look at heart rate. They didn't have a mask on. They weren't collecting VO2. They weren't doing intermittent, where they were step testing up to VO2 max, versus collecting heart rate data during a VO2 max test, which is very typical. And what they saw was that almost always the heart rate during a dedicated max heart rate test was higher than the heart rate they found during a VO2 max test. So these two don't always coincide. In fact, maybe something about the VO2 max testing, the mask, the protocol in this case tends to result in them not actually hitting maximum heart rate. So this was an interesting result that we don't talk about too much, because typically we tend to say that VO2 max and heart rate max happen at the same time, at least during a treadmill test. But that doesn't have to be true, and you can hit VO2 max without actually, or you can hit VO2 max at different heart rates that are close to, but not necessarily at, true max heart rate. Now, about a week ago, I sent out a Twitter poll where I asked Twitter followers, competitive endurance athletes, which training or racing situation most often takes you to your highest heart rate, your heart rate max. And one of the choices was stochastic, but I'm not going to show you more. So we'll come back to this and the results. But the question is what the next study looked at, which is, do laboratory tests or races or field tests give better or worse measurements or estimates of maximum heart rate? So this is the study that I think is worth looking at to address this question. This is from 2002. Again, I think it's kind of underappreciated because it's very robust. A lot of data was collected. Now, in this case, there were fewer subjects, but they did a lot of testing. 16 males, 20 to 39 years. They were triathletes, training quite a bit, 18 hours a week. Not a real high VO2 max, but not that atypical for non-elite athletes. So one thing they did was 5 different treadmill tests in the laboratory. The first was a traditional, what we call an incremental test, where you start with a warm-up at a steady velocity, 10 kilometers an hour, so that's below your threshold, and you're just warming up. And then after 10 minutes you start increasing, and they did increases 2 kilometers an hour every 2 minutes until they were at 80% of their 3 kilometer speed, their best 3,000 meter speed. And at that point, then the stages became 1 kilometer increments and 1 minute stages. So just a little bit slower climb to exhaustion. So that was the traditional incremental test. Then they came back and on different occasions in random order, they did so-called runs to exhaustion. So 30-minute warm-up or a good warm-up, and then a run to exhaustion at specific speed. 83% of their VO2 max velocity from the incremental test, or 86%, or 89%, or 92% of that velocity. Okay, and this was in random order. Now, then they did 5 additional tests in the field. So now we're up to 10. They did 5 field tests that are more or less known. Some of them were kind of uniquely French, but the Cooper test is well known in the United States. They also did a 5-minute maximum running test, which is just run as hard as you can for 5 minutes. They did a run to exhaustion at 94% of their measured velocity at VO2 max. They did what's called the University of Montreal track test, which I'll show you in a moment. And they did something called the Brua test, which is another published test, but I couldn't find it, or it was in French, so I'm not exactly sure what that was. But the University of Montreal track test is not that unlike some other kinds of tests where you do a standardized protocol out in the field, particularly on a track where everything's stable conditions and level. And so this is the Montreal track test, and then they had connected that or related it to the same athletes doing VO2 max tests on the treadmill, so they were able to generate regression lines that gave an estimate of VO2 max for these given speeds at exhaustion. Now, obviously, economy and things like that lead to some individual variation, but this was the Montreal track test, and their correlation with VO2 max was 0.96. And then finally, these athletes did 5 different road races over a period of 3 months. So a 7.5 kilometer race, a 5K, a 10K, another 10K, and then a 15K. So some variation in duration, a little bit of difference in temperature, particularly the first and the fifth, but this was across 3 months. So in all, 15 different tests of peak heart rate in each of these athletes. Now, so the first thing is looking at that lab testing, the treadmill testing. So they call these treadmill sessions where you gradually increase the velocity, triangular treadmill sessions, meaning that you're going towards a higher and higher velocity, whereas the steady speed to exhaustion test they call rectangular treadmill tests. So that's where that lingo comes in. But what you see is that the triangular tests, which tended to be somewhere in the middle on duration, about 19 minutes, that gave the highest peak heart rate. The test to exhaustion at these different speeds generally did not bring these athletes up to their actual maximum heart rate, even though they were exhausted when they finished. In theory, if you're above the second turn point or above critical power, people will say that you will hit VO2 max and maximum heart rate at exhaustion. But that doesn't necessarily turn out to be the case. At least it wasn't in this study. You also see differences in blood lactate pretty clearly. Now, here is the data from the 5 races, 5 road races. The subject number is here, so 16 subjects across are the 5 races they did and their times. And you see that, the 5K race is in the 15 to 18 minute range, and then the longest, the 15K race, is about an hour for most of them, 50 minutes to an hour. So some variation in the duration, which obviously means some variation in the average running intensity, but we know heart rate is drifting up. So does it drift up to max? Well, here we see, I put in red which race the athlete hit their highest heart rate. There were a couple that basically hit the same heart rate in 2 different races. Is there any clear difference? Well, in general, they didn't hit their peak heart rate or maximum heart rate in the longest race. But otherwise, there was some variation. And maybe if you had to pick one, it would be the 5K. That's the one that takes my daughter up to maximum heart rate for sure. So 5K or about 20 minutes, 15 to 20 minutes seems to be sufficient in terms of intensity and duration to drive heart rate up to max. But 10K may do it as well. Now, here is when you put it all together, the 5 lab tests, the 5 field tests, and the 5 competitions, the 5 races. Here are the results for each subject. Here is their heart rate peak. Here is what is seen in the lab. This is from during the VO2 Max testing. This is lab, field, and competition. And then I've highlighted where they actually saw the highest heart rate. And you see it's spread. And the average across everyone is the same, plus or minus a beat or two for all 3 situations. But at the individual level, you see there's a reasonable range. It averaged about 6 beats, but there were a couple that were very different. Not sure why. That would be very unusual, hard to explain for me, or hard for me to give you a good explanation why, for example, this person would have a 25 beat higher lab result unless they were just terribly unmotivated for the field and competition testing. So back to this question, when I asked current athletes which of these situations in a time when you have digital, avatar-based racing indoors, you have all kinds of possibilities, field testing, you have good possibilities for collection of heart rate data without going to a laboratory, which of these do they find to be the best for finding their max heart rate? And it was very close, but 34% said that hard interval sessions were a good way for them to find their maximum heart rate. A smaller percentage used these typical time to exhaustion or time trials that in other words, a 6-minute all-out run or a 6-minute cycling test or a 20-minute cycling test all out. Another type of situation that seems to bring a lot to maximum heart rate are these what we call stochastic races, these races with a lot of variability, a high average power but some fluctuation. That's what works for me. If I do on Zwift the 20-minute crit city races, then those will very often take me to the highest heart rate I see, and it's very consistent as long as I'm rested. Now if I'm tired, then a few beats lower. But in this data with 870 people who answered, only 9% said that longer time trials were sufficient or would bring them up to maximum heart rate. And that kind of makes sense, is that, and it's consistent with that lab data and the published data, is that these longer efforts, longer races, even though you're working very hard, you have a high perceived exertion, you do have cardiac drift, the heart is a slave to the actual muscular work, and since you're not at a muscular activity that's sufficient to drive heart rate all the way up to max, usually during those longer events, you don't see maximum heart rate. So that's an attempt at answering the question related to how should I test heart rate. There's a few issues. You need to be fresh. You need to be warmed up well. That's important. And generally, you need, if you're a cyclist, then you're going to test in cycling. If you're a runner, running. If you're a triathlete, in general, running is going to give you the highest heart rate. There tends to be some variation: run, bike, row, swim. This is related to, in part, the postural situation, the what we call the orthostatic position, and how it affects your stroke volume, which then in turn affects heart rate a bit. But it also is related to active muscle mass. For those who are not well trained on a bike, they may not be able to hit maximum heart rate before they hit voluntary exhaustion, because their local muscular training is not specific to cycling. And then, of course, there is a long-term age-related decline, but that's not something you're going to notice from week to week or during a season. However, these bigger issues of good warm-up, coming rested to the test, and choosing the appropriate modality, those are important. So with that, I will stop. Have a good day.